Hello, my name is Fernanda Sobral, and today I'm going to solve the two quizzes we did a week ago about simple harmonic motion. So the first quiz says, a 2-kilogram object is attached to a spring and placed on a horizontal smooth surface. A horizontal force of 20 newtons is required to hold the object at rest when it is pulled 0.2 meters from its equilibrium position, the origin of the x-axis. The object is now released from rest with an initial position of xi 0.2 meters, and it subsequently undergoes simple harmonic oscillations. Find. So it has several different parts that go from A up to G, so we're going to do by one. So letter A is the value of K, the force constant of the spring. So as we know, the equation for K according to Hooke's law is that K equals the absolute value of F divided by X, which in this case we know, which are 20 divided by 0.2, and this should equal 100 newtons per meter. So that's answer for letter A. Then B, the frequency of the oscillations. So for this case, we're going to use the formula that tells us that W equals 2 pi divided by T, which is the same as 2 pi times the frequency. So we know that W equals the square root of K over N. So we have this value. So all we have to do is say that frequency should equal the square root of K over N divided by 2 pi. We have K, which is 100, and we have N, which is 2 kilograms. So this is the square root of 100 over 2, which is 50, divided by 2 pi. And this gives us a total of 1.13 hertz. So that's the answer. This was like a 3 hertz. So that's the answer for letter B. Letter C says the maximum speed of the object. So, as we know for a very simple formula, the maximum speed should equal the amplitude times this angular frequency. So the amplitude is 0.2 as stated by the problem, and the angular frequency we obtained here, this should be equal to the square root of 50. So it's this times the square root of 50. And this should give us a total of 1.41. And this takes place, meters per second, of course. This takes place at when x equals 0. What we mean with this is that it is the origin of the x-axis, which is when it's completely pulled. Because that's when it will be like most urge or impulse to move. So that's when you will have a higher velocity. So I will erase this to continue with the next steps. So letter D asks us to find the maximum acceleration, which is equal to the amplitude times W squared, omega squared. So sorry about that. So this should be 0.2 meters times the square root of 50, and this will equal 10.0 meters per second to the square. And this will happen whenever it's at the highest or smallest value of L of A. So sorry, because this is when it will have like the most force attracting it to return to the equilibrium position. Then letter E asks us to find the total energy of the system. So again, we can use a formula. This should be equal to 1/2 of K times A to the square, which equals 1/2 of 100 times 0.2 to the square. And this should equal 2.0. The answer should be 2 joules for the total energy of the system. So letter F asks the speed and G the acceleration of the object when its position is equal to 1/3 of the maximum value. So these are the two last parts. So we are going to do as follows. Let me just write this information. So we have to do it when x equals 1/3 of the amplitude, in meters of course. And we know that the value that we just obtained for the energy, which is 2, should be equal to 1/2 of the mass times the velocity squared, which we have, it's 2 kilograms, plus 1/2 of the constant which we calculated at first, times x squared. So from here we can obtain this value for b, and we substitute x here, and well, the values we already calculated, no? The energy, the mass that was given at the beginning, and the value of k. So at the end, the absolute value for this should be the square root, as we can see here, of k over m times a to the square minus x to the square. And this is a formula that can be obtained from this. So when we substitute the values found here, we obtain that the maximum velocity equals 1.33 meters per second. So for the acceleration, we use the formula we used before, which says that it should equal the angular frequency to the square times x, which is this value here. It's not 0.2 because that's the amplitude, but this value here, complete. So this should equal 3.33 meters squared per second. So those are all the answers for the first quiz. The second quiz involves a little bit from physics 1, because it deals with forces. There's my dog. So the quiz is as follows. The figure, which is something like this that I'm about to draw, very professionally, because I'm a very good drawer. So it shows two masses, okay? So it's this. Mass 1 and mass 2. The figure shows a mass M2 of 2 kilograms. 20 grams, sorry. 20 grams. On top of a mass 1 of 20 grams as well, so this is for both, okay? Which is attached to a spring with K equals 10 newtons. It also says that the coefficient of static friction between the two masses is 0.6. So if we remember from physics 1, it's represented like this, 0.6, well, wait, so 0, 0. The masses are oscillating with simple harmonic motion on a frictionless surface. So the question is, what is the maximum amplitude the oscillation can have without M2 slipping off M1? So in order to solve this, we have to remember a little bit from physics 1 and remember how to build a free body diagram. So we're going to do so for M2. So we have the mass here, M2, and it has different forces, right, that are applied on it. So first, it must have, well, this is not a force, but it must have some acceleration, which goes, let's suppose that the spring is coming here, so it goes that way. We also have the friction force from the contact with the other mass, which should equal this times m2g. And we have the own weight of the mass, right? m2g as well. So we know that also from, we just saw it on the last quiz, that the maximum acceleration should equal the angular frequency to the square times the amplitude. And this is equal to k over m, the whole thing, right? So this m should be the total mass, which means the mass of the system, because the spring is working on both masses. That's very important to remember. So what we're going to do is first try to find all the equations that we're about to use, and then we're going to use them all together. So we know that this should be, let's say, m1 plus m2, which should equal 40 grams, okay? So we can also remember the second law of Newton, which is that the force equals the mass times the acceleration. So in this case, we're going to focus on mass 2, because that's the acceleration we're trying to find, right? So it's this. We know that A max should be equal to this, and this should be equal to this. So we can turn this into m2 times k divided by m1 plus m2 times A, right? So this equals this above. And we know that this force should also be equal to this we have right here. So we can make these two equal. M2 leaves the equation, and we have all the values here but the amplitude. So this amplitude here should yield what we're looking for. So by using both the equations we know from simple harmonic oscillation, which are these, and our information from physics 1, we can achieve this new equation. And when we take A out of it, we get that mu is, well, the friction coefficient, it's not printing anymore. So it goes like this, divided by K should equal the maximum amplitude we're looking for, as we are talking here about the maximum acceleration and the maximum force, which should lead us to the maximum amplitude. So we substitute the values here. This is 0.6, 9.81, 10, and here it's important to remember to take this from grams to kilograms, and we get a final answer of 0.02354 meters, which is also similar to 2.35 centimeters. So this is like the approximate answer, right? So due to the significant figures. So this is like the maximum amplitude this oscillation can reach before the mass above slips of the mass below. And that's all for today. Thank you.